Hold on. All right, sorry about that. Hello and welcome to another uh, special edition of my algebra videos. All right, I wanted to talk to you guys about factoring by grouping, but before we do that, let's talk about different type of quadratics. Now, remember how I said that quadratics is all polynomials that kind of look like this with a constant term, linear term, and a quadratic term being ax squared. We were talking before, let me erase this real quick. Remember, the ones we were talking about in class were the ones that equaled the ones with a equals 1. Well, what if a does not equal 1? Then a couple of more things matter. Prime example, if we do this right here, obviously a equals 1 in this case right here, and we factored this. So say we factored this, got our two binomials. I list the factors that I'm going to use here. Now, since I have an x squared, just a regular old x squared, and x goes here and x goes here. Why? Because if I fold it back, x times x would give me x squared, right? So we took that there. Now, using the factors, why is that eraser there? All right, using the factors, we know what our last term is going to be, right? Because using that adds up and gives us 6x, doesn't it? So we put a 1 here and a 5 here. Doesn't really matter. We can go 5, 1, 1, 5. It doesn't really matter. And since this is positive and this is positive, then that means that both of our signs on our binomials are positive. See? Easy. Nothing to it, right? But what if we had a polynomial that was not the case? For example, 2x squared plus 11x plus 5. Now things are different because we're not leading with an x and x term. All right, let's do this and find out what we get. All right, so here notice that it's not going to be x and x anymore because if we fold that back, that's not going to give us 2x squared. So in this case right here, what's going to give us 2x squared is 2x and x. So we took care of our first term. Our last term, once again, we're using 1 times 5 because that's the only thing we can use. However, it's going to matter where the 1 and the 5 actually go. Remember, we're trying to add up to give us 11. I'll show you really, really quick. Imagine if we put the 1 here and the 5 here, right? Notice that both of our signs are positive. So since both of our signs are positive, both of these signs are going to be positive no matter what. Is that the factored version of this? And the only way to find out is just take care of the outside and the inside. That will tell you. If I took care of the outside and the inside, this will be 5x, this will be 2x. Does that combine to give you 11x? No. So putting the 5 and the 1 there did not necessarily work. So I'll get rid of the 1. I'll get rid of the 5. Actually, I'm going to have to rewrite that because the eraser was too big. Oh well. I'll take that. Let's move that back. And I'll put that. Now, that's not true. So the thing is that it really matters where our 5 and our 1 go. If I put the 5 here and the 1 here, let's see if that works. We look at our inner, that's going to be x. And we do our outer, that's going to be 10x. You combine those, that's going to give us 11x. So everything is taken care of. So that's why it matters a lot that where those go. I'll give you one more example so we can move on. Let's talk about 3x squared plus 5x minus 12. If we talk about this right here, once again, it's going to factor into two binomials. Those two binomials that it's going to factor into is coming up. First, let's list our factors. 1 times 12, 2 times 6, 3 times 4. We're going to use one of those. Now, in this case, remember, we have 3x squared as our quadratic term, don't we? So the thing is, we're not going to use x and x or 2x and x. Instead, in this case, we're going to use 3x in x. Now, they're going to get tricky once you get to higher quadratic terms and stuff. You have to figure out which ones you're going to use. They're going to have more than one. They're not just going to have one like 3x, 2x, and x does. But we'll get to those. In this case, now it's really going to matter because if you notice, this means that the signs on the binomials are going to be different. So it comes to find out, like, which one are we going to use? Looking at it, I would use 3 and 4. But where does the 3 and the 4 go? If in fact you can put, and the thing is, the 3 would go here and the 4 would go here. So if in fact I did that and I fall back, some way, somehow, you have the 4x here, and on the outside, that's going to give you 9x, right? So if that gives you 4x, that gives you 9x. Some way, somehow, they're going to give us 5x, right? Now, notice that this one says that the signs are different. And this over here tells us that the larger one is positive. You would think that this 4 right here is the larger one, right? But it's not. The reason why is because when it's foiled, it's just 4x. But when the outside is foiled, that's 9x, which makes the 3 technically the larger one. So it gets the positive sign, and this gets the minus sign. When you do that, when you foil negative 4x and this together, you get negative 4x, don't you? Well, negative 4 and x together, you get negative 4x, right? And then positive 3x and positive 3 give you 9x. You combine those, you're going to end up with 5x. Easy enough, right? We'll do more of those later. In the meantime, I want to get to this. I want to get to my little slideshow that I put together for you guys. You're welcome. Whoa, too far. I want to talk to you about factoring by grouping. Now, the thing is with factoring by grouping, remember we have 3 different types of factoring. Man, too much. Let's do this. I got this. Yeah, there we go. Remember, we have 3 different types of factoring. 1, we have common factors, right? 2, we have my good old buddy Dobbs, difference of perfect squares. And then 3, we had quadratics, right? Now, factoring by grouping kind of deals with all of these right here. So you can use grouping with all of those. Oh, I'm going off the screen, but you get what I'm saying. So you can use all of those with grouping, which is why it's a form of those kinds of factoring. Let's move on. Distributive property clearly states this. So if the distributive property states that BA plus CA equals A in there. So really looking at it, need my highlighter now just to show you. If you look at it, these right here, the A's right here and here, are being factored out, right? It's being factored out here, and you're left inside with B plus C. That's what distributive property says. Now, it's basically distributive property. The common factoring is basically backwards distributive property, just what it is. Anyway, what if A wasn't a monomial like it is there? I know a lot of people get tripped up when it's not a monomial. Instead, what if it's a polynomial? You can still do the same thing. So in other words, let A be x plus 1, which is clearly a binomial, right? We do the same idea. It's the same exact idea. So if I go across some more, you'll see that you'll see that we do the same exact thing here, where you have x plus 1 in here for A, here, and in here. You factor it out the same exact way. If you factored x plus 1 out, so say, let me change this one more time. And let's say my pointer option, I'm going to go back to my pen. Say, for example, there are parentheses around this, like that. There are parentheses. You're taking the x plus 1 out of the parentheses. And what's left inside? B plus C. Make sense? Good. Let's do an example. Here, say once again, there are parentheses around this, just like that. What these two terms have in common, what this term and this term have in common, is x plus y. It's in parentheses, so it's kind of like one thing. They have x plus y, so what you want to do is if we take x plus y out of those parentheses, you tell me what's left. The 5 is left, and the w is left. So that's what's left inside the parentheses, so we have 5 plus w. And guess what? You're done. Easy enough, right? Let's do another example of this. It says that this right here. Now, when you get a polynomial that has like 4 terms, you might want to look to group because it'll really help. It's really going to help later on. So let's try this one. Obviously, looking at it, no kind of factoring could be done. So let's try grouping. What I want to do is group this term with this term and this term with this term. You take the signs with it. And then in between, let's put a plus sign. But they're still technically grouped together, right? So, with that being said, you rewrite it. So let's rewrite it, make it look nice and neat. Well, as best as I can. So that's going to be p cubed minus 3p squared. That's in parentheses, plus 2p minus 6. Right? So then, why don't you just factor them individually? So factor this part. If I factor just that part, I would end up with p squared on the outside, and what will be left over is p minus 3, right? Over here, what I have in common with 2p and 6 is 2, don't I? And what's left inside is p minus 3. Now notice that this term and this term have p minus 3 in common. So since they both have p minus 3 in common, I can factor that out. So if I had parentheses around this whole thing, I'd take p minus 3 out of the whole thing. And if in fact I did that, what do I have left? I have p squared plus 2. And you're done. So easy enough. All right, so we will talk about more grouping in class. That's the end of this video. Not too long. Took care of you.